Sketching linear graphs using the y-intercept and gradient method. So, the graph of a linear relationship is called a linear graph. And to be able to draw a linear graph, like we were talking about in previous exercises, we need 2 points that we can join together and rule a line to actually make that rule work. So before we keep going, we need to remember what we've learnt so far. We need to remember that y equals mx plus c is the general formula for a linear equation, where m, as you should know, is the gradient and c is the y-intercept, where the graph, when we draw it, will hit the y-axis. So we also need to remember what the m stands for. We know it's gradient, but we need to remember what that means, that it's the slope and that it's rise over run. And this is going to help us here, like we did before, to rise and run from one point to another and draw a line so we can have our graph. So don't forget these past rules that we've learnt for now. So let's start with an example. We're going to sketch this graph. So there it is there. Y equals 2 over 3x plus 1. Doesn't look so bad really. And I just want you to take a second to have a look and see if you can figure out for yourself what the gradient is and what the y-intercept is. Because we did in the last tutorial, we went over this kind of thing. Underneath I'm just going to write down the general rule so we can match things up, we can compare. So straight away I can see that m equals 2/3 in this example. The gradient is 2/3. So I'm going to write that down here. M equals 2 over 3. And my y-intercept is 1. So c equals 1. Oh, that's supposed to be c. Y equals mx plus c. That's my mistake. But it is 1 in this example. So, if I get some blank graph paper now, I should be able to draw a picture of it. So I'll give you a second to set up your graph paper. Oh, look, I've already got one already set up. There it is. I'll move this up a bit. So I'm going to draw a graph, and in maths we always draw our graphs in pencil with a ruler. So this should be in pencil, and you need to have your ruler handy, because linear graphs you can't try and join them up without a ruler, otherwise they're not completely straight. So the first thing we're going to do now is we're going to look back to our y point. I'm going to move this back for a second. Our y-intercept is 1, but what does that mean? I'm going to draw a quick blank. Actually, we could probably look at it here on here. Y-intercept. So wherever our graph is, we're talking about where it hits this axis, this vertical axis. Where is our graph going to hit? And you'll notice that anywhere along this line here, what's the value of x? Anywhere along this line. It's like I've gone to 0 on the x-axis. That's 0. And I've drawn a line straight through 0. So the rule when when we're finding the y-intercept or the x-intercept, it works the same with the x-intercept. So if I'm drawing a line that goes straight through here, or straight through here, or straight through here, anywhere it goes straight through, what's the value of y right along here? Again, y is 0. So before we keep going, I'm going to write that here, and you can remember that too. When we're finding the y-intercept, x is always 0. Always. And similarly, when we're finding the x-intercept, y is always 0. That's something we have to remember. So let's go back to our c that we found, our y-intercept. Our y-intercept here is 1. And no matter what our y-intercept is, x has to be 0 when it's the y-intercept. So if I had to write that as coordinates, I could write, because x is 0, y is 1 when x is 0. That's how I could write my c as a coordinate, 0, 1. And if c was 5, I would write 0, 5. Or if c was 70, I'd write 0, 70. But it's 1 here, so I know that this point, 0, 1, is part of the graph that I'm trying to draw. So I'll just pull this down a bit. And there is the graph that I'm going to be drawing. I might, so we can see the whole question. Okay. So I've gathered that the point 0, 1 right there is part of my graph. I can't draw the line yet because I don't know anything else. Well, I do know more things, but I haven't put any other points on my graph. One other piece of information that we have and we haven't used, because remember, in a question you have to use every piece of information that they give you. We haven't used the gradient yet. And we remember that the gradient is rise over run. So, watch what I do here for a second. If I rise up 2 and I run 3, I'm going to put a big old dot there, just like that. That point is also going to be another point on this line that I'm trying to draw. And the reason I know that is because the gradient from one point to the next on this particular graph is 2/3. So from every point I rise 2 and I run 3. If I wanted to find another one, I don't need another one, but if I wanted to find another one, I could rise 2 again and run 3 again, and there would be another one right there. But now that we have 2 points, like we've had in previous exercises, we can get those 2 points and rule a line that goes through them both. Just like that. And you'll see I've drawn that line as far as my page goes. And I'm going to show that that line keeps going by putting an arrow at either end, because the thing about linear graphs, unless they're restricted, which you'll learn about maybe next year, they keep going and going. So there's no use just drawing your line till there and stopping, or drawing it till there and stopping. You have to draw it over as long as your graph is, and show that it's going to keep going by putting those arrows on either end. The last step to a perfect graph is to writing down the equation of the graph that I've actually drawn. So if someone looks at it, they don't have to actually figure out what the equation is. They can just look. So I'm writing down the equation they gave me in the first place, next to the line. Oops, that's a 2/3 x plus 1. So now that's basically my graph finished. I've graphed a linear equation, and now it's a linear graph now, and that's what it looks like. So that's one example. We might do one more, and we might do a bit of a different one. Okay. Just find what I've done with it. Here it is. Okay, so let's sketch this graph. Okay, so you probably look at that and think, oh, that's not set out right, something's wrong with that. And in I think it was 4.2, we learned how to rearrange these so they look like linear graphs. Yes, it was 4.2. So, remember, if we have it looking like this, then we can easily look at the gradient and the y-intercept and draw a graph like we've just done. So let's transpose it. I'm writing it out again. And I'm making y the subject. You all know how to do that. I'm going to move this over here. Remember, there's more than one way to do this. As long as you get the same answer as me, that's what you should be looking for. 2x equals 6 plus 3y. 2x minus 6 equals 3y. Y equals 2x minus 6 divided by 3. And another way I can write this out, see how it's all a big fraction? That divided by 3 means that everything on top of the fraction is divided by 3. So, 2x is divided by 3. So I've got 2/3 of x, and 6 is divided by 3. Simplify it again. 2/3 of x, 6 divided by 3 is 2. So there's my equation, but I'm not just trying to find the equation, I'm trying to sketch it. So let's do that. So looking straight away, I want you to take a second to write down what the gradient is and what the C value is, which is the y-intercept. This method, by the way, is just one of the ways that we can draw a graph. Just depends what information we have. So next lesson we'll be learning about other ways to sketch graphs. Okay, so here's a graph that we can use. Straight away I can see that my m is 2 over 3. So every 2 that I'm rising, I need to run 3. But first of all, my y-intercept is -2. So remember before, our rules on the other page said that when you're finding the y-intercept, x is 0, and when you're finding the x-intercept, y equals 0. So if my y-intercept is -2, then x has to be 0. Because that means that on our graph here, that's that point right there where it hits the y-axis. So that's one point that we know is on the graph, 0, -2. And I haven't labelled my graph yet, that's very bad of me. I'm just going up by ones like I did before. That's x, that's y. Alright, so that dot there is 1 point. Now you should remember what we did before. We looked at the gradient. To find another point, we need to rise 2 and run 3. So let's try 1, 2, run 3, 1, 2, 3. This time, this is our second point. We can keep going and find more points, but you only need 2. Having 1 isn't good enough. So there you go, join the line. Actually, we might even put the points in this time too. In the last graph we didn't put the points in. But that is my line there. I'm going to write down what the equation of the line was, because initially we found that just here we found that it was y equals 2 over 3x minus 2. Or you could write down what we were told it was in the beginning. That is still correct. So here's my graph. The only other thing I might label is the y-intercept, and maybe even that other point that I found, which was 3, 0. And that's probably as hard as it's going to get for the first few questions of exercise 4.3. I would like you to try starting a selection of them. I would like you to try questions 1, 2, 5 and 6. The rest we will do next time when we learn a different method. So that was questions 1, 2, 5 and 6 from exercise 4.3. Good luck.